Now, before we go any further, you need to know that this system operates on the amateur radio bands, which requires a license and a brief test to get that license, and that's not for everybody. If that's you, you're not out of luck. There's lots of other systems you can use like GMRS, but if you find that those systems don't provide the performance level that you need, maybe keep this one in your back pocket and don't write it off quite yet. The test is very easy. If you've passed your driver's license test, you've passed a test harder than the amateur radio license. If you've passed high school, you've definitely taken and passed tests harder than this one. Additionally, everyone in your family who's going to use this system would need to be licensed. And that's where it gets tricky. A lot of guys I talk to, their wives are just not interested at all in getting an amateur radio license. It might be worth having a conversation with her to find out what her exact concerns are with it and come up with some strategies to mitigate those concerns. Maybe watch our overview video with her. I've set the system up to be as wife-friendly as possible, and my wife really enjoys using it. In fact, it's so easy that even my kids can use it with supervision, which is lawful under the FCC guidelines. Our system is built from multiple access terminals, creating something of a mesh network. We have one terminal in each of our vehicles, and then a central hub at home. Using the FSQ modem on the FLDigi software, we're able to route messages throughout that network and greatly expand our reach. I'm very grateful to AD7MR and N1OUT for teaching me about FSQ. Now, each terminal consists of an antenna, a power supply, a radio transceiver, a small computer, and some way to access that computer. You can see behind me here in my vehicle, I access with an HDMI monitor and a Bluetooth keyboard. Now, your wife or other people in your family might not want an HDMI monitor up front. There is a clever way around that, which I learned from The Tech Prepper here on YouTube, and I'll show you how I applied that here. This is the access terminal in my wife's vehicle. As you can see, everything is tucked away out of sight here in this little compartment next to the battery. We keep it plugged in when not in use, because the idea is you shouldn't have to reboot these things constantly. Over here, I've got a radio transceiver interfaced to a Raspberry Pi 2 computer using a DigiRig sound card. Audio alerts are handled with a small speaker connected to the AV jack. This unit has a Wi-Fi adapter plugged into the USB port, which outputs a Wi-Fi signal using the Tech Prepper's plans. Now, this doesn't mean it's connected to the internet. What this does allow is my wife to connect to the Raspberry Pi computer over a VNC connection using her cell phone or tablet. Now, I mentioned you don't have to reboot these things very often, so I ran an uptime command for you. 285 days is how long this little unit has been up. You really don't have to reboot these things often at all. We're here at my workbench, which is where I have our home access terminal set up, and that becomes the central hub for the entire system. Below the desk here, I've got a Pi Model 2, which runs this terminal. And if you don't know, that is an old, slow Linux computer, but I'm doing that to prove a point. You don't need the latest, greatest, most expensive equipment to run this type of a system. You can do everything you need to do on a slow, affordable little Linux computer. Now, you see another HDMI monitor and Bluetooth keyboard? I told you could use that to access the graphical user interface of the computer or a wireless VNC connection. In this case, I've actually got both going, and that allows me to remote in with this laptop here or my cell phone or whatever, and I figure that's probably a good safety measure because it's only a matter of time before this thing blows up or somebody spills coffee into that thing. But also, I'm going to be able to log in and record some video for you to demonstrate how our system works, so let's check it out. Okay, here we are having remoted in to the home terminal, and we've got FLDigi running, which is our communication software, and the modem is FSQ. If you have no idea what I just said, don't worry. We're going to do a deep dive into both because they're both really stellar programs. Now, up here, I've got these hotkeys, or macros as they're called, to help make this program just as user-friendly as possible. I've got all of our terminals listed out here, plus that routing information I mentioned that you can route messages through the network. We've got that all set up so nobody has to remember exactly what to type or make any typos. Go ahead and punch my Yukon, and I'm just going to type hi and press enter. Now you can see I've already got this set up with a command. It'll be the pound sign. It'll come back up here in a moment. Sorry about that. And that tells my Yukon to bounce back an acknowledgement when it received my message. I think this is really important because if you don't know that your information was received, if you have no acknowledgement, you have half of the communication, and that's no good. It's just going to bring back a little acknowledgement here after it's done. Now, down here at the waterfall is what this is called. You see all of this visual representation of our signals coming in and out. That lets us know everything's going on. And you just heard our ringtones. I'll show you how to set that up too. It's very difficult to find information about that anywhere on the internet, and I am going to show you that here in future videos. Let's go ahead and do one of these routing ones. We'll bounce it between the Yukon and the Volvo, and that'll give us a lot of time to talk about the extra features. So we can just type hi again and press enter to send. That's a really fun feature of this mode. There it is going out over the waterfall. Now FSQ is great because it will send pictures, it will send, and you can pull little text files, which unlocks a lot of potential in these systems for sharing telemetry. I have this set up to populate information about the health of the computer, such as its uptime, its processor temp, its load average. I have even figured out a way to get it to do GPS coordinates. I'm going to share all of this with you. Here, we've got the message routing through, and in a time, it's going to route an acknowledgement back to me. One other thing that I'd like to show you is if you right click here, you've got a lot of characters here, operator characters, that will tell your other systems what you want them to do. For example, if I click this one, it's going to have that system tell me what my signal to noise ratio is, and that is basically how loud my signal is over the noise, all the other noise that it hears. And FSQ will decode messages down to about negative 14 decibels below the noise floor, and that is really spectacular because if you think of it as a person whispering, there's our acknowledgement, a person whispering inside of a really loud, crowded room, and you can still understand them. That's essentially what's happening here. The other operator characters, we can go through all those later. One of them will be, for example, we can pull that file, and I'm going to give you an example of that. Wrong terminal. This is my wife's car here. We're going to read that uptime file that I told you I stored. This is going to be the same thing that we looked at in the terminal of her computer earlier, but we're going to pull it by radio. How cool is that? I'm just going to click OK. All right. This is going to take some time, so we're going to pause the video. We come back, we'll talk about everything that we see there. All right, I think it's about done. Now what we're going to see is the exact same uptime information that you would get by punching it into a terminal of a Linux computer. We've got our uptime, which is 286 days now. We've got 2 users have logged into this, and the load averages, which are not exactly clear. We'll go into how you can tell what the health of your Pi is by looking at that load average. I hope I've given you some things to think about. I hope you're interested. Come back for more on the terminal element.